So we solved some problems, and now we'll list what we have so we can think about what we did. When we had a linear factor, so something that was, remember, px plus q, that would be a linear factor. One of the ways that we solve for a, b, and c, the values on top, where we substitute roots. So that might be like, if remember we had something like, x minus 1, then if we set x equals 1, we know that part of it would go away. It would be 0. And for repeated linear factors, that's like px plus q to the m, where m is greater than 1, we use the coefficients from number 1 up there to rewrite the equation. And then we'll substitute other convenient factors. Substitute other values for x to solve. Okay. Now for quadratic, we had to do a little bit more. It wasn't as straightforward. So the first thing we wanted to do is, remember, we wanted to expand the basic equation. We multiplied out and we found out all our x squared terms and such one. Then we collected our terms according to x. So I'd have my x squared terms and my x terms, maybe my x cubed terms, whatever it was, and I'd have the coefficients with those. So what we're going to do is, with that, we're going to equate the coefficients of like powers to solve for a, b, and c. So like we did, we said, oh, there was no x cubed term. If I had ax cubed, and over here there's no x cubed term, that implied that a was 0, and we can go from there. We can use that value to solve for b and c. So after we do that, we just solve bilinear equations. And then we're done. So that's sort of what we did. It's written down sort of step by step.